Good morning, it's December 7th, and this is your daily brief in science. Here's everything you need to know. Scientists from the University of Oregon discovered a new method, the Ross Droplet technique, for grinding coffee beans. The technique involves adding a small amount of water to coffee beans before grinding, reducing static electricity buildup and clumping. This results in a more consistent and flavorful espresso and could save commercial coffee companies money by reducing the amount of coffee beans needed. The technique could also benefit pre-ground coffee. The study, published in the journal Matter, could help in understanding granular materials and their interaction with water. A new study shows organs age at different rates, and accelerated organ aging is linked to a higher risk of disease and premature death. Stanford University researchers have developed a blood test that can assess the rate of aging in internal organs. The blood test analyzes levels of thousands of proteins to predict which organs may be at risk of failure. The test could potentially be used to predict disease risk and measure the effectiveness of interventions to reduce aging-related illness. Further research is needed to determine if the identified proteins cause the aging process or are byproducts. Experts stress the importance of considering overall health and providing support to individuals receiving these test results. Researchers at Harvard University and Quera Computing Inc. have made a significant breakthrough in error-corrected quantum computing. They have built a logical quantum processor with up to 48 logical qubits, beating the previous record by more than 10 times. The quantum processor uses reconfigurable atom arrays and color codes for fault-tolerant operations. The team has shown the ability to perform multiple operations and correctly address errors. This development indicates the potential for large-scale, fault-tolerant quantum computing. This advancement is expected to lead the way for more powerful and practical quantum computers. A recent study has found that modifications in mRNA molecules used for therapeutic treatments and COVID-19 vaccines can produce incorrect proteins and trigger off-target immune responses. Specific modifications, 1-methylpseudouridine and N1-methylpseudouridine, were identified as causes for these errors. Researchers have discovered that by altering the mRNA sequences, they can reduce these errors and prevent unintended immune responses. This discovery is crucial for ensuring the safety and reliability of mRNA-based therapeutics, including vaccines. Researchers have conducted studies on human limb development using advanced sequencing technologies. Findings reveal distinct cell clusters and gene expression patterns associated with different stages of limb development. The research enhances understanding of genetic regulation, tissue architecture, and cellular processes in limb formation. Insights into the molecular mechanisms may help explain congenital limb malformations. Researchers have created a spatial cell atlas, revealing new links between developmental cells and congenital limb syndromes. Understanding limb development at a cellular level could improve diagnosis and treatment of limb syndromes. The study analyzed thousands of single cells from donated embryonic tissues, identifying 67 distinct cell clusters. The research has implications for understanding complex anatomical structures and for healthcare. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates at www.brief.news. And for more daily podcasts about the topics you love, visit www.brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.